So third column 0 into 2 0, 1 into 1 1, and 0 into 2 0. Again now third row first column 0 into 1 0, 0 into 1 0, 1 into 2 is 2. Now third row second column 0 into 3 0, 0 into 1 0, 1 into 2 is 2. Alright, now third row third column 0 into 2 0, 0 into 1 0, 1 into 2 is 2. The same result A has been obtained. Same matrix has come 1 3 2 1 1 1 1. This is what the fourth property for unit multiplication with unit matrix of any matrix A, if multiplied to unit matrix, it will give us the matrix itself. That is the fourth property we have talked about. It's the fourth property of matrix multiplication. Now fifth property, which I'll discuss in detail when I take the fourth lecture series, because inverse and adjoint of matrix I'll take in detail, but let me write that with the inverse property of matrix multiplication. Okay, so this is the fifth property. Property number 5. Inverse multiplication. Inverse multiplication or multiplicative inverse is possible. Inverse multiplication of a matrix is possible if determinant of A is not equal to 0. Determinant of A is not equal to 0, because this we know. What is A inverse? Inverse matrix of inverse matrix is possible when it is adjoint of A divided by determinant of A. Now determinant of A, if it is 0, then is not possible, is not defined. A inverse will not be defined. Multiplicative inverse is possible only when determinant of A is not 0. Okay, so multiplicative inverse is possible, or inverse A inverse is possible only when determinant of this, or multiplication, in case of multiplication with this, or A into A inverse, A into A inverse is equal to A inverse into A is equal to I. This is possible. Or A into A inverse is equal to A inverse into A is equal to I. The identity matrix will be obtained if we multiply them. So this I'll do in the fourth lecture series, because the reason is that in the fourth lecture series I'll talk about adjoint of matrix and inverse of a matrix. How to find out inverse of a matrix. That is in detail. The number of questions I'll talk about. Okay, but in this only multiplication and addition I'll talk about in this lecture series. Okay, so this illustration, I'll just talk about what is adjoint inverse of a matrix, what is multiplicative inverse of a matrix. That I'll talk about in fourth lecture series. This is the fifth property of matrix multiplication. It says that inverse multiplicative inverse is possible, or inverse of a matrix is possible only when determinant of A is not equal to 0, or determinant of A is having some value, is not equal to 0. Because if it is 0 in the determinant or in the denominator, then it will not be defined, or something upon 0 is not defined. It's indeterminate value or indefinite value. Okay, so this is what A into A inverse equal to A inverse into A is equal to I. This is the identity matrix. If is obtained when we multiply A with inverse of this, or inverse of A into A, the matrix itself, then it will give us the I identity matrix. This is the fifth property. Let's take question number 7. So question number 7, let me talk about. This is the fifth property which I'll discuss. This multiplicative inverse, what is the inverse of a matrix, in lecture number 4 series. Okay, so lecture 4 series I'll talk about this. Now this is question number 6. It's taken a lot of time. No problem. Now 7th question. Compute AB and prove that AB is equal to 0 does not imply A is equal to 0, B is equal to 0. Here A is something, B is something. Now we will prove here that AB is equal to 0. Okay, multiplication of these two is coming out to 0, but that doesn't mean that A is 0, B is 0. Because in case of multiplication, simple multiplication or scalar multiplication, A into 0 is 0, B into 0 is 0, or both, either of them is 0 or both are 0, then it is multiplication is 0 in case of discrete multiplication. But in case of multiplicative, matrix multiplication, AB comes out to be 0, A into B comes out to be 0, or matrix multiplication of A and B is 0. That doesn't mean that A is 0 and B is 0, or either of them is 0. That is what this question says. 7 question. Okay, question number 7. Let me talk about it. It says if A is, what is A here? This is 1, minus 1, 1. This is minus 3, 2, and minus 1. Alright, this is minus 2, 1, and 0. And B is 1, 2, 3. It is 2, 4, 6. It is 1, 2, 3. 1, 2, 3, 1, 2, 3. Alright. Then we have to prove. We have to find out here AB. So then prove that AB is equal to 0 here. AB comes out to be 0. To find, let me find AB. To find AB multiply or multiplication of A into B and prove that AB is equal to 0. But that doesn't mean that A is 0. Here we see that A is not equal to 0. A is not a null matrix. B is not a null matrix. So either of them is not 0. That means but AB comes out to be 0. And multiply AB. Solution. Or proof here. What is solution here? So in case of multiplication, let me write AB, multiply them. So write both the matrices together. Or both are of 3 by 3 matrix. So multiplication is conformable, or both are conformable for multiplication. A and B can be multiplied, or multiplication of A and B is possible. 1, minus 1 and 1. This is minus 3, 2 and minus 1. Minus 2, 1, 0. B is here 1, 2, 3, 2, 4, 6, 1, 2, 3. Now let me multiply them. Here they are conformable. Here A and B are conformable for multiplication. Are conformable for multiplication. Why conformable? Because number of both are of same order. I mean they are square matrices, 3 by 3 order. Undoubtedly the number of columns of A is equal to number of rows of B. That is there, so that means A and B are conformable for multiplication. Now let me multiply them. So multiplication. Now again, this is first row, second row, third. Corresponding multiplication with first column, second column, and third column. So first row, first column. Multiply correspondingly 1 into 1. Let me write them in detail. This is 1 into 1 plus minus 1 into 2. Minus 1 into 2 plus 1 into 1. This is first element here. Okay, then first there are 3 elements. Let me write them in brief. Then second element of first row. To obtain that, we have to multiply first row to second column. 1 into 2 plus minus 1 into 4. Minus 1 into 4. No, 1 into 2. Plus 1 into 2 is the second element of first row. Okay, now first row multiplied to third column correspondingly 1 into 3 minus 1 into 6 plus 1 into 3. Okay. Now this is equal to, let me check what it comes out to be. But before that, let me multiply now second row first column. Corresponding, this is minus 3 into 1. Minus 3 into 1. 2 into 2 plus 2 into 2. Minus 1 into 1 plus minus 1 into 1. This is second row first column corresponding multiplication. Second row second column. So this is minus 3 into 2 plus 2 into 4 minus 1 into 2 plus minus 1 into 2. Second element of second row. Now second row multiplied to third column. Open third element of second row. This is minus 3 into 3 plus sign 2 into 6, 2 into 6 and minus 1 into 3. This is plus minus 1 into 3. Okay. Then minus 2 is now third row, first column, minus 2 into 1 plus 1 into 2 plus 1 into 0 into 1. And this is 0 into 1. Minus 2 into 1, 1 into 2, 0 into 1. Corresponding multiplication. Now, third row, second column. Third row, second column will give us second element of the third row of the product matrix. Okay, so this is minus 2 into 2 plus 1 into 4 plus 0 into 2 plus this is 0 here, 0 into 2 here. Okay, no problem. Or this is 0 into 2 here. Now third column, third row. This is minus 2 into 3, minus 2 into 3, 1 into 6 plus 0 into 3, 0 into 3 here. For the corresponding multiplication, let me just write. What do we find here? This is 1 minus 2 plus 1. This is 2 minus 4 plus 2. This is 3 on the 3 minus 6. Well, minus 1 into 6 is minus 6 plus 3 into 1 positive 3. Then minus 3 into 1 is minus 3 plus 4 plus minus 1. Well, minus 1 into 1 is minus 1. Again, minus 3 into 2 is 6, minus 6. 2 into 4 is 8. Minus 1 into 2 is minus 2. Again, this is minus 3 into 3 is minus 9. Plus 12, 6 into 2, 12. Minus 3. Alright. This is minus 2 plus 2 plus 0. Minus 2 to the 4, minus 4 plus 4. 0 into 2 is 0. Plus 0. This is minus 3 to the 6 plus 6 on the 6 is 6 and plus 0. What do we see here? All elements are 0 because 1 plus 1 1 or 1 plus 1 2, 2 minus 2 is 0. Minus 4 and 2 plus 2 4, so minus 4 plus 4 is 0. 3 plus 3 6 and minus 6 0. All elements coming to be, so it's a null matrix here. Minus 3 plus minus 4, minus 3 minus 1 is minus 3 minus 4 is, sorry, minus 3 minus 1 is minus 4 and plus 4 0. Minus 6 plus minus 2 is minus 8 and plus 8 0. Minus 9 and minus 3 is minus 12 and plus 12 0. Again minus 2 plus 2 0. Minus 4 plus 4 is 0. Minus 6 plus 6 is 0. Which is a null matrix we see. It is a null matrix here. Null matrix. But here doesn't mean that each matrix is 0. Each matrix is null matrix. We see here A is some matrix, B is some matrix, and different values are given. So this doesn't mean that A is 0, B is 0. But here A, B result comes out to be 0, 0. What is a null matrix here? So hence it is proved. It doesn't mean, it does not imply that A is 0, B is 0. This is what we have to prove here. Here A is not 0, B is not 0, but AB is 0. This is what, that if AB result comes out to be 0, then it doesn't mean this scalar multiplication. In case of scalar multiplication it is possible, but if resultant of two values comes out to be 0, then either of them must be 0 or both are zeros, then it is 0. But in case of matrix multiplication, if multiplicative matrix comes out to be null matrix, that doesn't mean that either of the matrices is 0 or both of matrices are 0. It has been proved here. It is proved here. Okay, so seventh question we have done. Seventh question is proved that we have seen that AB is 0, but that doesn't mean that A is 0 and B is 0. A is something, B is something. That means A is not 0. A and B both are not null matrices. Now let me prove questions here. What is question number 8 says? This is another property to prove here that AB whole transpose is equal to B transpose into A transpose. That is the point here. This transpose matrix. So transpose matrix is obtained by interchanging the rows into columns. Okay, so the resultant matrix will have the rows converted into matrices. This is what matrix is obtained. But in case of multiplication, if AB is multiplied and its transpose is calculated, then B transpose into A transpose. What is the resultant? Both of them comes out. That must be equal. So let me prove this. Here we have to prove that A B multiplication whole transpose. The transpose of AB multiplication is equal to B transpose into A transpose. This we have to prove. Okay, so this is solution here for proof. We are finding out proof of this. Let me prove this. So let me take again A from numerical value. Let me take so that it can be easily proved. Okay, if A is equal to, let me take simpler one so that it is proved. It is again, let me take a square matrix. This is 0, 3, 2, 1. Okay, and let me take B is again a square matrix. 3, 2, and this is 5, 4. No problem. So we have to multiply them first AB, then transpose that. Whatever the resultant matrix comes out to be in the left hand side. The left hand side, let me prove this left hand side. We have left hand side. We have to find that AB whole transpose. What is that resultant matrix? AB, let me first find AB. Here AB, so A matrix is this 0, 3. First A, right? And then we both are conformably here because number of columns of A is equal to number of rows of B. Rows are 2 of B and columns are also 2, so that is equal. So they are conformable for multiplication. That I have taken here according to that requirement. This is 2 and 1. So A matrix we have written down. This B matrix here. This is 3, 2. This is 5. Let me multiply them first. So resultant matrix will be what? So 0, this is first row, first column, then second column. First row, first column. 0 into 3, 0. Plus 3 into 5, 15. Let me write directly. Then first row, second column. 0 into 2, 0. Plus 3 into 4, 12. 12 here. Second element of first row. Now second row, first column. 2 into 3 is 6, plus 1 into 5 is 5, again 2 into 2 is 4, plus 1 into 4 is 4. The resultant matrix comes out to 15, this is 12, 11, 6 plus 5, 11, 4 plus 4, 8. This is AB matrix, but we have to find out AB whole transpose. Transpose of this. Therefore, AB transpose, this is AB here. Okay, now AB transpose, therefore, transpose matrix will be AB transpose. Let me write here. We have to obtain the transpose matrix of AB multiplicative. This is AB matrix. We have to transpose this now. So, transpose of this matrix multiplication or this product matrix of AB, it will be write rows as columns and or columns as rows. Rows as columns. First row will become as 15 and 12. First row we have converted into column. Second row 11 and 8. This is AB whole transpose. What we have done? First row written as first column. Second row written as second column. This is converted rows into columns. Interchanging rows into columns or changing rows into columns will give us the transpose of a matrix. This is AB whole transpose. Let me write here. So AB whole transpose matrix is this. It is 15, 11, 12 and 8. 12 and 8. Okay, so this is 15, 11, 12 and 8. This is left hand side. This is your left hand side we have taken. So let me now find what is right hand side. Okay. Now we have to find out what is right hand side. So first we have to find out what is B transpose and A transpose, because B transpose into A transpose. First B transpose. We have B transpose will be this transpose B matrix 3 2. First row, first column. First row will become first column. Second row will become second column. 5 and 4. This is B transpose here. What is A transpose? A transpose, transpose this is 0 3. First row will become first column. Second row will become second column and 1. Now we have to multiply them. B transpose into A transpose. Whether that also comes out the same, then we say yes, AB whole transpose equal to B transpose into A transpose. Now therefore, B transpose into A transpose will be the first side B transpose is 3 5 2 4, and this is A here. A transpose, B transpose into A transpose. A transpose is 0 2 3 1. Okay, so resultant of this, let me add up this. So the resultant of this will give us, let me write here, this is B transpose into A transpose which we are calculating. First row, first column, then first row, second column, then second row, first column, second row, second column. In that way we have to find out the elements of this. So first row, first column, 3 into 0, 0. So 5 into 3, let me write 5 into 3, corresponding multiplication of the elements. Now first row, second column, this 3 into 2, 3 into 2, first element into first element, second element to second element, 5 into 1. Okay, now second row, first column, 2 into 0, 0, plus 4 into 3, 4 into 3. Now second row, second column, 2 into 2, plus 4 into 1. This will give us 5 into 3, 15, because 0 plus 15 is 15 only. 3 into 2 is 6, plus 5 into 1 is 5. 0 plus 12, that is 12 only. 2 plus 2, 4, plus 4 into 1, 4. It is giving us 15, 11, 12 and 8. Is it the same? 15 and 11, 12 and 8. Same. That means AB whole transpose equal to B transpose into A transpose. So matrix multiplication is possible in case AB whole transpose equal to B transpose into A transpose. This has been proved now, because same result is obtained. Left hand side is equal to right hand side. Therefore, this implies that AB whole transpose equal to B transpose into A transpose, or left hand side is equal to right hand side. Hence proved. This is the question number 8. Okay. Algebraically, we can take Aij, Bij, the two matrices are there. They are of the same order and multiply, or I mean, they have the. Let me take Bil, then Lj. The resultant matrix will be Ij. Okay. Then multiply them. So I mean, transpose them. Transpose, but we have to take them square matrices, and it is possible. That will be easier then. Okay, so that can be algebraic. Question number 8 we have done. Let me take question number 9 here. What is question number 9? Let me check it. Now, ninth question is, okay. Now, question number 9. It says that if A is equal to this, B is equal to this, find the product AB and BA, so that AB is not equal to BA. This we have proved, but again let me take this easily. Here, if A is equal to, this is 1 3 0. These questions are asked by the students, okay, in the class. and as well as online students. Okay, online queries have come. Those questions are taken here because of that multiplying, proving that AB is not equal to BA and AB. This is, we know the commutative law doesn't follow for matrix multiplication. So that is the point here. A matrix is 1, 3, 0, minus 1, 2, and 1. This is 0, 0, and 2. This is matrix A. Okay, A matrix is 0, 0, 2, minus 1, 2, and 1. And B here is 0, 2, and 1. This is 3, 1, and 0, 0, minus 1, and 2. Okay, I'm sorry. 10th, this I have written down 10th one. But 9th one is, I'm sorry. 9th one is, in 9th B is 2, 3, 4. 2, 3, 4. This is then 1, 2, 3. And minus 1, 1, and 2. This is B matrix in question number 9. Now show that find product, what we have to find out, find product AB and BA, and then prove that AB is not equal to BA. So simply we can multiply them and then show that AB is not equal to BA. Simpler one, but let me again find multiplication, show that is easily done. Let me check whether matrices given are same or not. 1, 3, 0, minus 1, 2, 0, 1, okay, 0, 0, 2. A matrix, this is matrix A here, 1, 3, 0, minus 1, 2, 1, 0, 0, okay. B is 2, 3, 4, 1, 2, 3, and minus 1 and 1, 2, minus 1 and 1 and 2. Okay, now A, B, we have to find out. So, solution. The solution we have to find out. We are A, B, we are calculating. Now, they are conformable because they are of the same order, 3 by 3, 3 by 2 square matrices. They are the number of columns of A is equal to number of rows of B, so they are conformable. Here A and B are conformable for multiplication. Here A and B are conformable for matrix multiplication. For matrix multiplication. This is what we write here. The number of columns of A is equal to number of rows of B. Both are of the same order, 3 by 3, 3 by 3. They are square matrices of order 3. We can say they are having the same. So they are conforming easily. Now let me find AB. So this is A matrix 1, 3, 0, minus 1, 2, and 1, 0, 0, and 2. Into B. B is 2, 3, 4, 1, 2, 3. I'm sorry, this is 1, 2, 3, minus 1, 1, and 2. Let me multiply them. Again, corresponding multiplication. First row, first column, then second column, then third column. Corresponding multiplication to find the element of the first row of the resultant matrix. This is 1 into 2. Let me write 1 into 2. Plus 3 into 1 plus 0 into minus 1. 0 into minus 1. This is the first column, first row. Now first row, second column, corresponding multiplication 1 into 3 plus 3 into 2 plus 0 into 1. 0. Okay, then first row, third column, 1 into 4 plus 3 into 3 plus 0 into 2. This is what we have obtained the element of the first row. Multiplication and addition, corresponding multiplication of the elements, then add them to find the one element. Now second row, first column, corresponding multiplication, this is minus 1 into 2, minus 1 into 2, 2 into 1 plus 2 into 1 plus 1 into minus 1 plus 1 into minus 1. 2 into 1 minus 1 into 2, corresponding multiplication. Now second row, second column. Now this is minus 1 into 3 plus 2 into 2 plus 1 into 1. Okay, 1 into 1. Now second row, third column, minus 1 into 4 plus 2 into 3, 2 into 3 plus 1 into 1 into 2. Now third row, first column, 0 into 2, 0. Let me write 0 into 2 plus 0 into 2 again. Sorry, 0 into 1. I'm sorry. This is 0 into 2, 0 into 1 plus 2 into minus 1. 2 into minus 1. First element. Now third row, second column. Now 0 into 3 plus 0 into 2 plus 2 into 1. 2 into 1. Now third row, third column. So 0 into 4 plus 0 into 3 plus 2 into 2. Okay, so what does it give us? It gives us 1 into 2 is 2 plus 3 into 1 is 3, 0 into something 0. 1 into 3 is 3, 3 to the 6, 6, 0 into 1, 0. 1 into 4 is 4, plus 3, 3 and 9 is 0. Minus 1 into 2 is minus 2, 2 into 1 is plus 2, this is 1 into minus 1 is minus 1, again minus 3, this minus 3 into 1, plus 2 into 2 is 4, plus 1 into 1 is 1. Minus 1 into 4 is minus 4, 2 into 3 is 6, plus 6 plus 2, 1 into 2, this is 1 into 2. Second element of, third element of second row. Now, 0 into 2 is 0, 0 into 1 is 0, and 2 into minus 1 is minus 2 only. Okay. 0 into 3 is 0, 0 into 0, 2 into 1 is 2 only. 0 into 4 is 0, 0 into 3 is 0, 2 into 2 is 4. This is the value. Final result is what? 3 plus 2, 5. First element, 3 plus 6 is 9. 4 plus 9, 13. 13 here. Minus 2 plus 2, 0, and minus 1 only. Minus 3 and, okay, 5 plus 4 plus 1, 5. 5 minus 3 is 2, positive. Minus 4, okay, and okay, 6 plus 2 is 8. 8 minus 4 is plus 8, plus 4. Then minus 2, 2 and 4. This is AB matrix. What is BA matrix? Let me find out that also. Now BA is also possible. The reason is they are conformal for multiplication. B and A are also conformal for multiplication. The return matrix is this. Now we have to do that BA is something different. Now BA